All righty, so the section we are in is partial derivatives. And I want to just do a very simple problem. So here's the example. All right, so S is a person's body surface area in meters squared. So those are the units. So S is equal to 2 times W to the 0.4 times H to the 0.7, where W is the person's weight in kilograms. And H is the person's height in meters. Okay. So when H is equal to 70, and W is equal to, nope, W is equal to 70. I'll get ready to say the person cannot be 70 meters tall. So that's got to be their weight in kilograms. And H is equal to 1.8. All right, find the partial of S with respect to W and the partial of S with respect to H. Okay, so now let's find the partial of S with respect to W. How would I find that, Anaya?
Yes.
How would I find the partial of S with respect to W?
Isn't it like the Greek letter alphabet? You start with that. No, you in the back of my thing. Shut up.
What do you mean the Greek letter?
What you mean find the partial?
Okay, so remember we're finding partial derivatives. So if f of x, y equals 2xy plus x squared minus 3y squared, I asked you to find the partial of f with respect to x. What would you tell me?
This calc 1, I need to get my cheat sheet.
Girl, where you been? This is calc 3. These are the partials. We did this yesterday.
Girl.
We took the derivative. You keep y fixed.
Oh my gosh, yes, you did. With respect to x, yeah, I remember now.
Okay, so take the derivative, the partial with respect to x of this function.
The first one you just posted?
This,
I mean, the
one, this f of xy, yes, ma'am.
So 2y.
2y.
Plus 2x.
Plus 2x.
Minus 3y squared.
Okay, 3y squared is a constant because I'm taking a derivative with respect to x. So it disappears.
Oh yeah, you did. It's respect to x, not y. Okay.
Okay, so now the partial with respect to y is going to be what?
2x minus 6y.
Good. Okay. All righty. So let's
lasso. Oh yeah, when you said yesterday, I had to remember we did do this yesterday.
We're gonna lasso this thing right on out of this corner. We're gonna move it over here because it. All right, that was just to help bring you back to your senses. because you seem to have disappeared on me for a minute. Okay. I'm like, I know, what talking about is this Calc 1? I'm like, what in the?
No, I thought you were talking about the partial decomposition that.
No, nope. Okay. So now I want you to find the partial of S with respect to W.
Oh, so the S equals.
So here's S. Find the partial of S with respect to W. So just taking the derivative, W is the variable, H is a constant.
So it would be 0.8
Good.
W minus, well, the 0.6. That's it.
This stays. That's still there.
Oh, I thought you said.
Okay, so if it's multiplied by something, it stays.
Oh, but if it's adding, okay.
But if it's added and sitting by itself, then then its derivative is 0.
Yeah, I know. I peeped because that's how it was with 2xy.
Yes, okay. You got it. Okay, so therefore, and then the partial of S with respect to H
would be, can you go back up a little bit?
Yes, ma'am.
0.14.
I think it's
1.4.
Okay.
Oops, my fault. 1.4. Do you want me to keep the W next to it or no?
Oh yeah, W.
0.4, and then H is negative 0.3.
Okay, so now in order to find them at the point where W is 70 and H is equal to 0.8, you just put that in there. So the partial of S with respect to W at the point 70, 1.8 would be 0.8. I'm going to have 1.8 to the 0.7 divided by 70.
We actually have to plug it in and find it.
That's what the problem asked you to do.
Okay.
It said when W is 70 and H is 1.8, find those things. Okay. So for this problem, it wants you to do it. So now this is 70 to the 0.6. So you just have to plug that in. And so you get 0.8. This number is 1.50901 divided by 12.79555. And this turns out to be 0.9435. Okay, and then the partial of S with respect to H, once you get 71.8, so I get 1.4. W is 70 to the 0.4 and divided by 1.8 raised to the 0.3. And this turns out to be 1.4 times 5.47065 divided by 1.19284. And that turns out to be 6.42.
Can I use a calculator on this or no?
Absolutely. Yes. Yes, okay. Yes.
Thank you.
Yeah. Yeah. Okay, so now life gets fun. All right. So given z equal to a function of xy, we have f sub x and f sub y are our first order partials. Okay, so fx and fy are the first order partials. That means I have taken the derivative. That's like the first derivative. They're called first order. Now we have second order partials. So our second order partials are like taking second derivatives, but which derivative do I take it with respect to? So I can start with f sub x, and I can take the derivative with respect to it again. So we call this fxx, all right? And the way we write this is if we took the partial with respect to x of the partial of f with respect to x. So we already had the partial of f with respect to x, and then we took another partial with respect to x. And
so it's like the second partial derivative?
Yes.
Okay.
And this becomes the partial squared of f with respect to x squared. Okay. Now, I could start with f sub x and take the derivative with respect to y. So that is fxy. So that says I'm taking the partial with respect to y of the partial of f with respect to x. So this becomes the partial squared of f. And now I have to write them separately with respect to y, with respect to x. Okay. I can start with fy and take the derivative with respect to x, and that would give me fyx. So that is the partial with respect to x of something I already know, which is the partial of f with respect to y. And that will give me the partial squared of f with respect to x with respect to y. And then last, I can start with the partial of f with respect to y and do a derivative with respect to y again. So I get fyy, and that is the partial of f. Oh, it's the partial with respect to y of the partial of f with respect to y. And that then becomes the partial squared of f with respect to y squared. Now, these two in the middle have a special name. They are the mixed partials. And they must be equal if the function is continuous. So if f of xy is continuous on a circular disk centered at AB, then the following is true. Then the mixed partial f partial squared of f with respect to x with respect to y at AB has to equal the partial squared of f with respect to y with respect to x, AB. So the mixed partials are equal. Okay. F x y is equal to f y x. Okay. Of course, if we have second order partials, we have third order partials. Now I'll give you a hint as to how many there are of those. So first order, there were 2 of them, that's 2 to the 1. Second order, there are 4 of them, that's 2 squared. Third order, there are going to be 8 of them, so that's going to be 2 cubed. So there are actually 8 different partials. So you have f x x x, f x x y is the same as f of x y x is the same as f of y x x. Then you have f of y y x is the same as f of y x y is the same as f of x y y. And then you have one more, which is f of y y y. Again, this group in the middle being the mixed partials. Okay. Here's an example. So f of xy is going to be e to the x sine of y plus the log of xy. And you need to find fxx, fxy, fyx, and fyy. Okay, get going. Are you working on it? Anaya?
Yes, yes, yes.
Okay.